Alright guys, so today we're going to talk about how to graph linear, quadratic, and exponential functions. So go ahead and pause the video, put the date down. It should be May 4th. It might be different on the day that you're writing down the notes. Today's title is this, and I am on page 7. I don't know about you guys. So write down the information, pause the video until you have it done. I'm going to turn to a new page and we are going to work on graphing linear, quadratic, and exponential functions. Okay, so a couple of characteristics. If we look at the graph versus the equation of the two, so linear, quadratic, and exponential. Okay, so alright, so if we look at the equation, if we have a positive slope for our equation, typically we have y equals mx plus b. Alright, so if we go back to our previous notes, we can review that our slope is the rise over the run, and it's the number that's multiplying. So it's with the x. Our y-intercept is the number that is adding or subtracting. So typically we have a slope and a y-intercept. Sometimes it won't be written in this form and we need to change it so that y is by itself. But you can have equations that look like y equals 2x plus 6. Maybe you'll have an equation that has a negative slope where it's negative 6x minus 8. Okay, so that's the equation. If we look at the graph of a linear function, the key thing is it's going to be straight. Right? So it's going to either go up like this or down like this. It might even just be flat. But those are my three options. A quadratic, what you want to look for, one last thing. On linear, the exponent is a 1 on that x. Okay, so x is raised to the first power. For quadratic, we want to look for x raised to the second power. So its equation in standard form is y equals ax squared plus bx plus c. Alright, and the thing that we want to look for in this one is that squared term is the highest. So linear, we have x is exponent of 1. This one has an exponent of 2. Now sometimes you won't have the rest of these. Sometimes you'll just have the x squared, or maybe you'll have the x squared and another x. So let's use one with numbers. So maybe we have x squared plus 2x plus 6. Alright. We have, this is our quadratic term because it has the x2. Our linear term is going to have an exponent of 1, so that matches up. And this is always called the constant. Okay, and that will be, again, just like this, our y-intercept. So we could, if it's positive, then my graph, it's curved, it has a vertex, and both ends are going the same direction. So what I mean by that is they're both going up. However, if my equation has like a negative out front of that x squared, so maybe it's negative 3x squared plus 4x let's say we don't have a constant, that's okay. If that negative is out front, then instead of it going up, it's going to go down. Okay, it still has a vertex. And its end behavior is still going the same direction. They're both going down. So that's a quadratic. So we've got a squared term. And this one, we always like to say it's like the happy face or the sad face. Okay. So think positive is happy, negative is sad. Exponential, what we want to look for is, let's just say we have a number down here, and the x is in the exponent. Okay. So the x is no longer being multiplied down here. It doesn't have an exponent. It is the exponent. So here's an example. So let's say we have y equals 2, and then the x is up top. We could also have a fraction as the base. Okay, right here the 2 is our base, so maybe our fraction is 1/3, and the x is up here. We could even add something to up here, that's fine, as long as the x is in the exponent. Okay, an exponential will either be going up like this or down like this. So it kind of looks like an L. All right, so maybe exponential ends in an L. All right, so it's slow and then quick, or quick and then slow. All right, so those are the types of functions. So when you are going to graph them, what I want you to do is use a table of values. Table of values. Okay, so we've already learned how to graph linear functions. So those I'm not actually going to go over, but I am going to go over the quadratic and the exponential. If you need more help with the linear, you can rewatch those notes or ask Ms. Jimenez or I for help. So example number 1, if I give you the function f of x equals x squared plus 2x minus 1. All right. What type of function is that? It's a quadratic. And we know it's a quadratic because it has the x squared. And there's no variable that's an exponent. So what we're going to do is just make a table of values. So like we said yesterday or in the last video, all right, we can pick whatever x's we want here. But I always like to have them center around 0. So if I put 0 in the middle, then I'm going to go 1 above and 1 below. And what we're going to do is we're literally just going to plug it into this equation. So I'm going to take up a lot of space here. So I'm going to show my scratch work over here. So if we have f of -2, then that is, we're going to take and plug that in for every x value. You guys learned how to do this in topic B. Okay, plus 2 times -2 minus 1. All right, so that is going to give us -2 times -2 is 4. 2 times -2 is -4 minus 1. Okay, so then my order of operations, I have to go left to right. So 4 minus 4 is 0. Minus 1 gives me -1. So f of -2 is -1. So that's going to go right here. All right, I'm going to repeat that process, but for all of my other numbers. So we have f of -1 is now -1 squared plus 2 times -1 minus 1. Do you see all the work I'm showing? I need to see you doing this as well. So -1 squared is 1. Positive 2 times -1 is -2 minus 1. Order of operations, I go left to right. So 1 minus 2 is -1 minus 1. f of negative 1 is negative 2. Okay. Next we do f of 0. So f of 0. Well, 0 squared minus 2 times 0 minus 1. We have 0 minus 0 minus 1. F of 0 is negative 1. Okay. Next we have f of 1, so we should get 1 squared minus 2 times 1 minus 1. And we get 1 minus 2 minus 1. Negative 1 minus 1 is negative 2. Alright, so f of 1 equals negative 2. Okay, what about f of 2? So we get 2 squared minus, or plus 2 times positive 2 minus 1. So we've got, let's see, this is 4 plus 4 minus 1. So 8 minus 1, f of 2 is 7. All right. So now we're going to draw the graph for this, okay? So a lot of my x values are, or sorry, my x's revolve around 0. Okay, so I can draw these in, or I can just use the grid, but since you guys are watching me, it's easier to do it this way. 1, 2, 3, 4, 5, 6, 7. That one's supposed to go there. Okay, so negative 2, negative 1. Negative 1, negative 2. 0, negative 1. 1, negative 2. Oh, I did this wrong. This is supposed to be plus. So that's a 3. That makes more sense. So 1. Got to be careful when you're copying down the equation. So it's adding here. So 1 plus 2 is 3. 3 minus 1 is positive 2. So that's a positive 2. So 1 up 2 and 2 up 1, 2, 3, 4, 5, 6, 7. All right, now something about quadratics is there's this thing called symmetrical. So this right here is our vertex, okay? And so it is symmetrical about where that vertex goes through. So this point is 1 away on the right, and this is 1 away on the left. So this point is from this line 1, 2. So now we're going to go 1, 2 away on the left. And we can continue to connect the line. So this one up here, from this line, we go 1, 2, 3. So we go 1, 2, 3. That's another way to finish out the graph. So now we can see that this is a quadratic and this is our vertex. Okay, now we're just going to do a quick one for exponential. So I need to turn the page. I don't know about you, but let's just do an example 2. So f of x equals 2 raised to the x. All right, and we're going to make a quick table of values. F of x. So if x is negative 2, negative 1, 0, 1, 2, we can start wherever we want. Oh, just kidding. When it's in the exponent, I want to be careful not to do any negatives yet. There's a special rule that applies for that. So we're going to just start with 0 and then go to 1, 2, 3, 4. Let's just do those. So I'm going to show my scratch work over here. 2 raised to the 0 power, anything raised to the 0 power is 1. So that's 1. 2 raised to the first power is just 2. 2 raised to the second power is 2 times 2, which is 4. 2 raised to the third is 2 times 2 times 2. Well, we know that this is 4. 4 times 2 is 8. 2 raised to the 2 raised to the fourth power is 2 times 2 times 2 times 2. This is 4. This is 4. 4 times 4 is 16. Alright, so see the pattern in this? It is doubling each time we go up. So if we make our graph, my x's are only positive, so that means I'm going to be in the first quadrant, and so are my y values. So 0 goes up to 1. 1 goes up 1, 2. 2 goes up 1, 2, 3, 4. 3 goes up to 1, 2, 3, 4, 5, 6. Oh, 4, 5, 6, 7, 8. And 4 goes up to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It's off the table. So it would be way up here. So my line is going to be very steep, and it's going to keep going up. Okay? And it would continue in this direction very slightly. So this is our exponential, and we know it is exponential because it has an x as an exponent. So x is the exponent. Alright, go ahead and start working on your con missions. I expect you to be making a table of values and then plotting the points.